Hello and welcome to the challenging parts of this course, part 5 on Boltzmann machines and part 6 on autoencoders, because in the following two parts we're going to make a recommender system. In fact, we're going to make two recommender systems. One recommender system that will predict if a user is going to like yes or no a movie, and another recommender system that is going to predict the rating of a movie by a user. So the first one predicts a binary outcome, 1 or 0, that is yes or no, and the second one predicts a rating from 1 to 5. And this way you have the two recommender systems that are mostly used in industry. Nowadays, many companies build some recommender systems, and most of the time these recommender systems either predict if the user, the customer, is going to like yes or no the product, or some other recommender systems can predict a rating or a review of some certain product. So there we go. We are about to create these two recommender systems. And so we're going to make the recommender system that predicts a binary outcome, yes or no, with our Boltzmann machines, the neural network that we will implement in this part 5, and then we will implement the other recommender system that predicts a rating from 1 to 5 in the next part, the last part of this course, part 6, on autoencoders. However, for both these recommender systems, for both these parts, we're going to start with the same dataset. This is the most real-world dataset that you can find online. It's of course the movie lens dataset. And speaking of this dataset, the first thing that we're going to do right now in this tutorial is to go online to have a look at this dataset. So, this dataset is available on this website, grouplens.org, then /dataset/movielens. So this dataset was created by GroupLens Research, and as you can see on this page, you have several datasets with different amounts of ratings. So for example, this one contains 100,000 ratings, then this one contains 24 million ratings, so that's the largest one I think, and then you have some older datasets, and that's the one we're going to use, with another 100,000 ratings from 1,000 users and 1,700 movies, and again an old dataset with 1 million ratings. So I strongly recommend to have a look at these datasets, download them, and of course I recommend to practice on these datasets and test your different neural networks, besides the ones that we're going to make, to see if you manage to get some better performance results. So to download these datasets, well, that's very simple. You just need to click on the links here. And so the one that we're going to work with is this ML100K, but I'm going to download this one too, because this one contains the informations of the users and the movies. So it contains additional informations which maybe can be useful to make the recommender systems even more robust. So there we go. That's the only real-world dataset with that many ratings you can find online. And so each time you want to test your neural networks for recommender systems, I highly recommend to use these datasets. As you can see, they're used for not only education and development, but also for new research. And in that case, the purpose of this dataset serves as a benchmark so that you can compare the different performances of your models. Okay, so good. Now let's move back to Python. All right, and now the important thing to understand is that even if we're going to make two different recommender systems, well, we have a common data preprocessing phase that we're going to do first. And so this data preprocessing phase takes 5 tutorials, and these first 5 tutorials are going to be the same for our Boltzmann machine and our autoencoders. And so these are going to be the next 5 tutorials after this one. So in these next 5 tutorials, we're going to import the dataset, prepare the training set and the test set. We're going to get the number of users and the number of movies because we're going to need them. And then we're going to convert our data into an array where we have our users in lines and movies in columns. And finally, in the last step of this common data preprocessing phase, we will convert the data into torch tensors. And then, after these 5 tutorials, we will start the steps that are specific to Boltzmann machines. That is, we're going to start dealing with binary ratings, then create an architecture of a neural network that will be a restricted Boltzmann machine that, I remind, is a probabilistic graphical model. So right now you're really taken at the next level. This part is probably going to be the most advanced part in terms of techniques of this course. And so hold tight, everything is going to be fine. Alright, so before we start this common data preprocessing phase, let's set the right folder as working directory. So I'm going to File Explorer, to my Deep Learning A to Z folder, then Volume 2 Unsupervised Deep Learning, and Part 5 Boltzmann Machines. Alright, before you were with Kirill for the intuition lectures, and now you're with me to implement our Boltzmann machine. And there we go. So that's the folder we want to set as working directory. So let's do it right now. Set console working directory. Here we go. We are now ready to start. But first, let's explain what is inside this folder. So first of all, you have this PDF file that is a file available online, and that contains all the theory behind the neural network that we're about to make. So I strongly encourage to have a look at this PDF file. If you can read it, that's really, really good. It contains all the theory explained on the intuitive level, but also it goes into the math pretty much in detail. We're going to have a look at this PDF in a second. And then, of course, we have our two data sets, the 1 million ratings dataset and the 100K ratings dataset. So remember, we're going to train our RBM on this one, the 100,000 ratings, but of course you can practice on this dataset as well if you want to evaluate more the performance. All right, and then of course we have our RBM Python file, which is of course this one. So now what we're going to do is have a quick look at this paper on restricted Boltzmann machines. Here it is. This paper is called An Introduction to Restricted Boltzmann Machines, and as you can see, it contains first an introduction, then all you need to know about graphical models, because a restricted Boltzmann machine is a probabilistic graphical model. So you have here the theory of graphical models with undirected graphs and Markov random fields. Then what do you have? You have a section on unsupervised learning. Well, that's great, because now we're in volume 2, unsupervised deep learning. So I strongly recommend to read that as well. And so as I told you, you have the mathematics, the mathematical details on the computations of the likelihood, the KL divergence, and some optimization theory, which is of course very useful for Boltzmann machines. And then you have some theory about MCMC techniques, Markov chain Monte Carlo techniques. So that's very important because we're going to use Gibbs sampling to estimate the gradient of the likelihood, and Gibbs sampling is based on MCMC. We'll see that with the random walk. So then you have the definition of a Markov chain. So that's, if you want to go deeper in mathematics, in details. And then you have, of course, Gibbs sampling. That's very important. That's at the heart of Boltzmann machines. And of course, we will remind the intuition behind Gibbs sampling when we implement our Boltzmann machines. So here, there you go. You have some more mathematical details. You have everything. And finally, you have, of course, our restricted Boltzmann machines. So after all this theory, you have now the formula for the energy that we're going to try to minimize, because we're trying to minimize the free energy, and that is by maximizing the log likelihood. All right, so here you have the architecture of the restricted Boltzmann machines with the visible nodes that are inputs, which are going to be the ratings of the movies by the users, and the users are going to be the different observations going into the network one by one. And here you have the hidden nodes, and so all this makes the architecture of the RBM, and that's exactly what we're going to make in Python by building a class. And mostly this class will contain the contrastive divergence technique that will be used to maximize the likelihood. And speaking of the contrastive divergence technique, I think it comes right after that. Well, first you have the gradient of the log likelihood that we're trying to approximate, and we approximate it with, there we go, the contrastive divergence technique. So in this class that we're going to call RBM, we will implement the contrastive divergence technique. And so that leads us to the algorithm we will implement in the following lectures, which is this algorithm, algorithm 1, k-step contrastive divergence. We will implement this exact same algorithm. So if you want, you can already try to implement it yourself just by following the logic here. And so this is this algorithm that is at the heart of our RBM. So this is very important that you have a look at this first. But don't worry, we will explain everything step by step, and each time we will take a step back to explain what we do so that we never get lost. Alright, so let's do this, but first let's take care of this common data preprocessing phase, and that's what we'll do in the next tutorial. Until then, enjoy deep learning!